Hello everyone, welcome back to my YouTube channel. Welcome to the third part of the series on MERN Stack. So coming to this topic, I'm going to be explaining you today about MongoDB, which is the first, the word which is MERN. The MERN M over there stands for MongoDB. So it's very essential to know more about the database you're using in any tech stack, right? Be in any full stack you're using, you need to understand what is the database you're using and also to understand how the database works, some of the features of the data set database and so on. So we are going to use MongoDB for MERN Stack development. So what is MongoDB? What kind of database it is? It's all going to be covered in this video. So if you heard about NoSQL and SQL, so NoSQL is basically not only SQL, and SQL is structured query language, right? This SQL is used for relational database system where you are having a database which is an organization or a collection of data where you are performing operations, like it can be any CRUD operations, create, read, update, delete operations, and so on. So when you're having a data which is containing only structured data, a database which is having only structured information and data, you're going with relational database. It has a schema, fixed schema to it. On the other hand, NoSQL database or NoSQL or non-relational databases, they have this feature of being a dynamic schema. They do not have any fixed size schema. They can have a dynamic schema, that is their size can be changed. They can handle not only the structured data but also the unstructured as well as the semi-structured data. That is the uniqueness of NoSQL or the non-relational database. So coming to this NoSQL database, we have this particular NoSQL database called MongoDB, which comes under the document based type of NoSQL database or non-relational database. So what is MongoDB? MongoDB is popular. It is open source NoSQL or non-relational database management system designed to store and manage large volumes of data, flexible and scalable manner, uses document-oriented data model, allowing storage of semi-structured and unstructured data. That was the introduction of MongoDB. Now, basically, before jumping to the features of MongoDB and explaining you why we are going to use MongoDB, I would like to also introduce you to this MongoDB platform. You can either go with MongoDB on premises or on the cloud. So MongoDB basically has this MongoDB is a database. You can also use the cloud, fully functional cloud service database, okay, the cloud platform of MongoDB, which is over here. This is the particular side of MongoDB. If you go to something called as MongoDB Atlas, so there is also documentation over here, by the way. So there are solutions, resources, and all for you to refer. If I just click on sign in, for example, I want to just show you the UI of how it is. This is MongoDB. You can sign up and create an account over here. Suppose you want to know more about MongoDB. So if you want to learn more about MongoDB, you can create an account in MongoDB Atlas. And for example, say there are resources over here and there is start with guides. Now, if you want to understand, how to get started with MongoDB and the Atlas. So there you can perform the CRUD operations over here, sign up for a MongoDB account and so on. So there was a particular site I would like to show you, which states how you could actually develop clusters in MongoDB and so on. So there is a site over here. In solutions or in resources, you have develop application. Yes, so over here, so in order to develop applications, it now depends on you whether you want to actually connect, basically at the end, when you are building a web application, a full stack web application, you have the front end and the back end. To the back end, you need to connect a database. So how it is up to you how you want to actually set the connection method between the database, how you want to link or connect your database to the back end. Back end, we have the Node.js and the Express.js. So how you want to connect it? Instead of Node.js, someone can go with Python, someone can go with PHP. So if you're using PHP, you need to connect it with another database, be it MySQL. So PHP, MySQL is a common tech stack. There also, there is some kind of a link, right? In that case, you're using something called as PHP MyAdmin. There also, you have the mechanism of links and drivers. So it depends on you how do you want to connect it. So if you see this over here in the MongoDB docs itself, there is to develop applications, you can either connect them with drivers. So drivers are to connect your application to database with official libraries. Then MongoDB for VS Code. If you definitely maybe you can go with any other ID also, but then I'm going to demonstrate it using VS Code. So you have this, VS Code has several options for you, especially for web development. So you can see how you can actually link your MongoDB database to your backend for VS Code directly. There is MongoDB Atlas tutorial as well for you to get started with. So coming to understanding about how to build databases in MongoDB Atlas and so on. When you just log into MongoDB Atlas, you will be able to see, if you see launch and manage MongoDB, then you will be able to understand that if you go to Atlas, if I just click on Atlas over here, because which is a multi-cloud database service. Now, when I say it's a multi-cloud database service, you have different the option of using different cloud service providers. Now, the top 3 cloud service providers, which are AWS, Microsoft Azure, and Google Cloud. So you can go with either of the 3 cloud service providers, and it simplifies deploying and managing your databases. So basically, when you click on get started over here, you can have a look as to how you can actually connect to your MongoDB database and link it to your backend. So there is exclusive documentation over here where you can do it either through CLI, which is command line interface, or using the Atlas UI itself, where you have to first create an Atlas account. You can use this link, register for an Atlas account, deploy a free cluster. So basically, you need a project first. You need to first make a project in the Atlas, in your Atlas account of MongoDB, and you can give any name to your project, then create a cluster. Inside the cluster, you are going to now give a database. You're going to manage a database. So for that, in order to deploy your database, you need to also add a connection IP address. Now, a connection IP address can be anything. It can be from either anywhere, or it can be your own, or it can be a specific IP address. You want only that IP address to be linked to your database, which you are using or hosting in the cloud or in the MongoDB Atlas account. So after this, creating a database user for a cluster, you can add more users of the database accordingly. Connect to your cluster. There is a connect option. Okay, so if you just click, or if you create a database, right after that you will get a connect button. So if you just click on the connect button, you'll be able to actually connect to your cluster. And after clicking the connect button, you will also have the option how you want to connect. So I was just explaining you can either connect it with MongoDB driver, or through directly through VS Code and CLI, or so on. So if you want to link it through a MongoDB driver, then you need a specific URL. It will give you a specific URL, and it also has the boilerplate code for you to actually use Node.js. So since we are going to use Node.js, right, we are going to use Node.js in the backend. It has the code how you actually linking Node.js, connecting Node.js in the backend to MongoDB. So that is going to be done using a library called as Mongoose, which will establish that connection. Mongoose is the library, by the way. So if you see that, there will also be a specific URL which you have to attach, or you have to actually paste. You have to copy that URL from your account, paste it, and put it inside when you're actually developing a web application. Paste it inside the one file which is called as a db.json file in the server side. Whatever you're dealing with the database has to be done in the server folder of your web application. Insert, then you can also insert and view a document. Now, before jumping into what is documents collections, you can also load sample data in MongoDB, by the way. You also have the opportunity, or the feature of visualizing your data beautifully as charts using MongoDB charts feature. Inserting and view a document. This can be done either programmatically by developers or through their UI as well, and by using MongoDB drivers. That was all about I would like to show you, and I would like to just want to get you started with what is MongoDB, the several features it provides, the UI, how it looks, and how you actually get started with your MongoDB Atlas account on the cloud. Which also has the feature. It is also paid as well as a free version. So if you want to first start as a free version, it gives you the option to actually deploy one cluster for free. Absolutely for free. So you can deploy your cluster for a project for free. So that was all about that. Now coming to the features of MongoDB, document oriented. So when I tell document oriented, see, compared to I would like to give you this analogy between relational and non-relational. That will be easier for you to grasp. So when I tell you about relational, you heard about the relational databases which you work on using SQL. So say MySQL. If you heard of MySQL, or be it SQLite or MySQL SQL Server, right, over there, those kind of relational database actually store the data in structured tables. So when you have tables over there, table definitely has a row and a column, right? The row is horizontal and a column is vertical. So similarly, and analogous to that, or similar alternative to that, similar equivalent to that in MongoDB would be, you have, instead of a column or instead of a row, you have something called as a document. So since you know that MongoDB is a document based database, right? It's a document based database. There is a collection. There's a concept of collections and documents. So in a table, of MongoDB that is called as a collection. Collection in a database, MongoDB database, you have a collection which is nothing but a table. Each row or record of that table or that is collection is called as a document. So there are several documents which are nothing but rows in collection. In MongoDB, data is stored in which format? It's stored in flexible format, which is JSON-like, that is called as BSON. Now, BSON format, which is binary JSON format, which is JSON-like. BSON documents can have varying structure and can include nested documents and arrays, making it highly very flexible, handling evolving and unstructured data. Scalability and performance, they're designed to scale horizontally across multiple servers or nodes. So in MongoDB, when you actually make a cluster, right, you will get to understand something called as a concept of nodes there. So when you actually make a cluster, when you create an account on MongoDB Atlas, you have to also create a project, then a cluster. And then inside that cluster, which is free, right, you're starting with a cluster. And then inside cluster, you're deploying a database, giving a name to a database, adding IP address, securing your database, and finally optimizing it. Then you have this concept of something called as nodes there. So what is nodes and replica sets? So these are nothing but node instances. I would say they're self-healing clusters. So when you talk in terms of nodes, so basically they are, you can treat them as servers, right? Nodes is nothing but a server. So they basically have, if you heard of the CAP theorem. So in NoSQL, all the databases of which is non-relational databases, they follow something called as a CAP theorem. CAP stands for consistency, availability, and partition tolerance. So MongoDB, it allows the CP part of it because in CAP theorem, at most or only up to 2 features can be followed in any kind of a database, be it a graph database, a column database, any database. So for MongoDB, it follows a CP, which is the consistency and the partition tolerance. So consistency means all the data will be available, whatever the client is seeing from any whatever a client sees is going to be the same and consistent among all the servers. So that is consistency, and then you don't have compromises on availability. So basically MongoDB is like where there is a node which is actually not working, then it is not like it is actually does not, it makes the unavailable nodes in case there is a partition tolerance or there is a partition intolerance or a fault occurring. So where there is any communication delay, connection failure, and so on, then you will see that the partition tolerance is not affected. You will see that the MongoDB is having the partition tolerance. It is partition tolerant. The connection is not lost, but it makes one of the clusters unavailable in case of a partition tolerance. So availability is compromised, but then you see that the partition tolerance and the consistency being intact. So that is the CP in in the MongoDB feature. So that is why it is highly scalable. Firstly, you should understand, and also why it is scalable is because when there are multiple nodes or multiple servers also, it is able to handle large amounts of data and high traffic loads, supports sharding. This is a very important concept in database. In database management system, sharding, which involves distributing data across multiple machines or replica sets, which provide high availability and partition tolerance. So, when you have various servers and the incoming requests, there is a lot of traffic, right? There should be some concept of distributing the traffic among different servers or handling the different multiple machines. So that is why it's going to divide the incoming traffic or distribute it among the different machines. That mechanism is called as sharding, supported by MongoDB. Querying and indexing. MongoDB supports a powerful query language to support complex queries and aggregations, allowing you to perform queries. Like what is query basically? Query is basically you're sending when a user sends a request. You can think it of like that. When the user wants to retrieve data from a database, that is again a query from a database, right? The user is sending some kind of a request to the database. Either it can be a select query, or it can be an update query, or you can even perform aggregation operations, which are grouping, or you can perform the other complex queries as well, joining the documents, joining rows, inserting. The user need not just always insert, right? The user can also just filter out and delete some rows. So delete operation, insert operation, all the CRUD operations, they can easily be performed with querying on the MongoDB, because MongoDB provides a set of functions or query language tools, and that is NoSQL query language. Then it performs aggregation operations like grouping and filtering. It also supports indexing. Indexing is basically, when you want to actually search or look for any document in a database. Indexing makes it very faster for faster retrieval. So for faster retrieval of a searching operations in any database, that is where indexing comes in, and it helps in optimizing the query performance. That is all about this features of MongoDB. Coming to the flexible schema, this is again very important. Flexible schema. So unlike traditional relational databases, MongoDB does not have fixed schema. As I've already covered, it has a dynamic schema. That's why very easy schema evolution, dynamic models, and beneficial for agile development and prototyping. Agile development is a concept in software methodology where the needs are always changing. There should be high flexibility. So wherever there is a concept of flexibility involved, and you see that agile is being used, right? Agile software engineering is being used, the methodology is being used, and MongoDB is very beneficial in that case because of its highly non-dynamic, a non-fixed, which is dynamic schema. That's why it is called as a flexible schema. Then high availability and data replication. It supports replica sets, which are self-healing clusters. As I've already covered, what are replica sets of node instances in MongoDB. They provide automatic failover and data redundancy, ensuring high availability and data durability. So there is a concept of CAP theorem, which is also involved. So consistency, availability, and partition tolerance. So this is followed duly in MongoDB. They also facilitate read scalability by distributing read operations across multiple replica set members. Rich query language and aggregation framework, because they support wide operations, functions, including filtering, sorting. Now, these all are database operations, right? If you are aware of what we can do with a database, definitely you can filter data. Database is a collection of data. So you have a collection or a table in MongoDB. It has multiple rows or records, which are called as documents. You can either insert new data into it, which is through the insertion operation. You can sort it, you can filter it out, project, joining. All these wide operations can be supported. The aggregation framework of MongoDB also allows you to perform complex data processing tasks such as grouping, filtering, calculating aggregates directly within the database. Full text search. This is again very important. It is very similar to indexing part, where when I've already told you that MongoDB supports high indexing, speeds up the time for searching any record in a database, right? Similarly, full text is basically the capability to perform text search queries across fields in your document. So fields are nothing but columns. You have the concept in relational database, they are called as columns. Here you have the concept of fields. So you want to perform some kind of text search queries. You can also do that in MongoDB because it supports all the, if you've heard of natural language processing, right? The terms text processing basically. So when you're dealing with text, you can either stemming. Stemming is basically cutting a text shorter, shortening a text. Text indexing, language specific search, relevance ranking, all these kinds related of text pre-processing or text processing tasks or full text search can be performed easily with MongoDB database. I hope I have given you a very good introduction of MongoDB for you to actually be able to understand what is MongoDB used for, its features, and why we are actually using it in the MERN stack. So stay tuned for the upcoming video where I'll be demonstrating you the code, especially now that you've understood all the concepts of front end, back end, and the database of MERN stack. Let's get into the development side where I'll be demonstrating you the code in the VS Code environment, showing you the code, each step. We'll be explaining you what libraries are used, why they come handy, and also we'll be showing you the functionality. So happy learning. Stay tuned and subscribe to my YouTube channel. Share with all your friends my YouTube channel, because I'm sure that it will help them to actually understand the key concepts of these development topics. And feel free to comment on my YouTube video if you have any queries, or with your feedback what videos you're looking for. And thank you very much.